Today we will be doing the last experiment for the semester, experiment number 13, weak acid-base titration. In this particular titration, I will give a very brief introduction and then show you the objectives for this particular experiment, followed by a small, quick demonstration. At the end of the experiment, as usual, you will have to get the pH curve and then calculate all the required items under the objectives so that you can complete your result, discussion, and conclusion. So an acid is a substance that generally has the hydronium ion when it dissociates in water. Strong acids dissociate or ionize completely, even in moderate concentration. However, weak acids tend to dissociate it to a very small extent, as a result of which they acquire equilibrium very quickly. To overcome the equilibrium, we have to go on removing the acid so that more and more of the acid will dissociate. And then when the acid is completely dissociated, then by reaction with the base, then we can get the endpoint of the reaction. Because we will be using a pH meter for this reaction, you will have to plot the graph. Now, how to plot the graph, how to calculate the various items for this kind of titration has all been previously discussed in experiment number 12. And so this is almost a repeat of experiment 12. Now, remember that weak acids or bases, they will not ionize. That means they will have more of the molecular formula of the compound in solution rather than the ionic form. And with that, I'm going to first share a Word document to indicate what are the objectives that I need you to determine for this particular experiment. There are 8 objectives that need to be completed. First, determine the volume of base required to reach the endpoint. Determine the pH at the neutralization point. When we have to determine the pH at the neutralization point, please remember you have to plot the pH graph. And the pH graph is available under the program for this particular experiment. Determine the molarity of the acid used, determine the grams per liter of the acid, determine the percentage of weak acid in the sample taken, determine the half volume for neutralization point. From the graph, obtain the pH at half neutralization point, calculate the pKa and the Ka for the weak acid. Now, you have to remember that as we come towards the pH from 6, 7, and 8, you will be using the Henderson-Hasselbalch equation, which states that pH is equal to pKa plus the concentration of the salt over the acid. And with that, I'm going to stop this share and then go to the next share that I want to do. And that is the Chem Lab. So we'll open the Chem Lab and then go to the file, open a new one, and go to the weak acid-base titration over here. And please note, I'm not going to take the exact volume as required in the titration, but you can check out, read the introduction, write it in your own words, and then make sure that you do not copy it. I do not want to be responsible for any plagiarism. All lab reports submitted go through the global search, indicating that I am looking for originality in words. And so too with the procedure, write it in your own words. Don't copy the steps as such. So there are two titrations over here. And so I'm going to do the first titration we have already done in experiment number 12. And so I'm not going to repeat it. I'm going to do the second part of the titration. But students in this class will do the first part completely as stated in the procedure, and then complete the second part and make sure that you complete all the objectives of the experiment. Remember that you have to copy the titration curve onto your report, and also the pictures at the neutralization point, so that I can get the details correctly for grading purposes. So get a beaker, 100 ml beaker, and into this beaker, first I'm going to add my chemicals. Add the volume that is asked for, and then I'm going to add the pH meter. Okay, if you see a pH that is 7, it tells you that you have added water. So go back and empty the beaker, remove the pH, remove the pH, go back, go to the chemical, and make sure you do not make a mistake of reading your chemicals like I did before. So it does happen, therefore be very cautious and cognizant about what you are doing. Put the pH meter in, and there you are ready for your titration. Then I'm going to get a burette. No, burette. Where is the burette? Get a 50 ml burette. You have your titration box there. Then add the chemical. Sodium hydroxide. Fill up the burette and say okay. And then I'm just going to lower it so that you can see. And then I'm going to open the titration dialog box. Collect the titration data. Then I'm going to go and view the titration graph. And so here is your titration dialog box. Here is the titration data. And I'm going, remember the burette is filled with 50 mLs of the base, but the starting volume is always 0.00. That's the maximum. The burette is not inverted, and therefore please read the burette reading correctly. The change as the volume is decreased from the burette is recorded under the heading of volume. And so start the titration, and you can see as it goes on, you will see that the titration curve is coming up. And also, you have to remember that when you are doing a pH meter titration, you will see a slight curve in the front. And then as it goes, the titration proceeds. I will discuss both these two curves that you are observing under your graph. So let's finish the experiment first. And then make sure you get a nice S curve. And then you close the graph. Now you'll see that this particular line, straight line portion is not exactly vertical, but it's slightly slanted. So in order to get the volume of base volume of base required for complete neutralization, select the midpoint of the straight portion, and then find out what the pH is to the left and what the volume is to the right at the bottom. And so record both those readings, which will be your a couple of objectives that you have met with. Now you can see this is a slanting curve and it is still an S-shaped curve. So looking at the direction of the S as well as the nature of the curve, it is possible to identify what the titrant is and what type of titration are you doing. Whether it's a weak acid strong base titration or a strong base weak acid titration or a strong acid strong base titration or a strong acid strong base titration. Now, that is how to read the graph and find out the nature of your titrant and the titer that you're using. In the case of the weak acid, you see that towards the left, you are seeing a slight curve that is there. This part of the curve represents a buffer action. That is initially when you add sodium hydroxide, the acid and the salt is formed. And the pH, according to the Henderson-Hasselbalch equation, is given by pH is equal to pKa plus the log of the salt, concentration of the salt over the acid. Depending upon the amount of acid added, the same amount of base will be neutralized. So as the reaction proceeds, the amount of acid decreases and the amount of salt increases due to neutralization. But the buffer action basically tends to resist change in pH. And you can see that it is trying to resist change in pH, but after some time, you can see that the system cannot resist the pH anymore, and then the pH gradually increases, and you get your standard curve that is there. And from this, it is possible to calculate the pH at any given time for the reaction that is there. Now, once you get the pH volume, then go to the half volume. Whatever the volume is, go to the half volume and hit the curve at the point where the half volume is, and then extrapolate it to the pH axis, and then determine the pH of the solution. That pH will be equal to pKa because at half neutralization point, the concentration of the acid and the salt will be equal. And with that, you can copy this by going under edit. You can copy it and paste it in your Word document. Complete all the requirements and then save your document. And with that, I'm going to stop the share and end the experiment.